Welcome to the 10th of 13 SPSS video tutorials accompanying the first edition of the text, Introduction to Statistics for Social Sciences. We will be using IBM SPSS Statistics version 19 for this tutorial. If you are running a different version of the software, you may notice some slight differences. In this tutorial, we will show you how to conduct an independent sample t-test and a paired sample t-test in SPSS. For this tutorial, you will need the file Chapter 10 videotutorialdata.sav. This dataset consists of 4 variables: group, writing, pre-quant, and post-quant, which are related to the measurement of various parts of the Graduate Records Examination, or GRE for short. Individuals applying to graduate school are often required to take the GRE exam as part of their application submission. 2 of the 3 components in the GRE include the analytical writing score and the quantitative reasoning score. Often, individuals will take a GRE tutorial course to assist them in preparing for this examination. We are going to test 2 hypotheses regarding the effect of the tutorial on GRE scores. In the first scenario, we have 2 independent groups, 25 individuals who took the analytical writing tutorial and 25 individuals who did not. The variable group is coded to reflect these 2 independent groups. The variable writing represents individual GRE analytical writing scores for those in both groups. This score ranges from 0, which is poor, to 6, which is excellent, and is measured in increments of 0.50. In the second scenario, all 50 individuals took the quantitative reasoning tutorial. Each individual wrote the quantitative reasoning component of the exam before the tutorial and again after they took the tutorial. The variable pre-quant represents their score prior to the tutorial, and the variable post-quant represents their score after they took the tutorial. Considering the first scenario, we want to know if there is a significant difference in analytical writing score between those who took the writing tutorial and those who did not. Specifically, we hypothesize that, on average, those who took the writing tutorial will have a higher writing score than those who did not. Since we have 2 independent groups for this scenario, we will need to test our hypothesis using an independent sample t-test. We get to the independent sample t-test by going to Analyze, Compare Means, and then Independent Samples t-test. In the Independent Samples t-test window, we move the writing variable into the test variable area and the group variable into the grouping variable area. We then click the Define Groups button and specify what code we want SPSS to use for Group 1 and Group 2. We will enter the code of 1, which represents those who did not take the tutorial, in the Group 1 field, and 2, which represents those who did take the tutorial, in the Group 2 field, and then press Continue. At this point, we can ignore the Options button and press OK. Since we are covering 2 different tests in this tutorial, we will only be highlighting the important parts of the output for each test. In the output, we are provided with 2 tables. The first table provides us with the group statistics. Here we can see that it appears that the mean analytical writing score for the group who did not take the tutorial is lower than the mean score for those who did. The second table provides us with the results of the independent sample t-test. You'll recall from the textbook that one of the assumptions of this test is the assumption of homogeneity of variances. SPSS provides the results for when this assumption has been met and the corrected results for when it has not. Since the test of homogeneity of variance is out of the scope of the textbook, and since most introductory textbooks present only the calculation of the independent samples t-test for when the assumption of homogeneity of variance has been met, we will ignore several parts of this table. First, we will ignore the Levene's test that is used to test the homogeneity of variance assumption. Second, we will ignore the results for when the assumption of homogeneity of variance has not been met. So consistent with the textbook, we will assume that the assumption of homogeneity of variance has been met and use the results on the top line of this table. The first thing we might look at is the mean difference. We can see that the no tutorial group had a score that is 0.78 lower than the yes tutorial group. This number is negative because the yes group is being subtracted from the no group. So the negative indicates that the no group is lower. We can also see that the 95% confidence interval of the difference in the means is minus 1.4595 and minus 0.1005. We read this as follows. We are 95% confident that the difference in the means for the population is between minus 1.4595 and minus 0.1005, meaning that in the population we could expect that 95% of the time the average score of those who do not take the tutorial will be between 1.4595 and 0.1005 points lower than those who do. Finally, we can see that the t-value is minus 2.308, has 48 degrees of freedom, and a p-value of 0.025. As we saw in the Chapter 9 tutorial, we can compare the p-value to our desired alpha value to determine whether to reject or fail to reject the null hypothesis. Assuming that we are using an alpha value of 0.05, we reject the null hypothesis of no difference because the p-value is lower than the alpha value. Therefore, we can say that the average score of the group who took the writing tutorial is significantly higher than those who did not. For the second scenario, we want to test if the mean quantitative reasoning score is higher after individuals take the quantitative reasoning tutorial. In this case, we are comparing the mean pre-tutorial quantitative reasoning scores to the post-tutorial quantitative reasoning scores. To do this, we will need to use a paired sample t-test. To obtain a paired sample t-test, we go to Analyze, Compare Means, and then Paired Sample t-test. Once the Paired Sample t-test window opens, we select the pre-tutorial variable and move it to the variable 1 cell in the Paired Variables area. Then we select the post-tutorial variable and move it to the variable 2 cell in the Paired Variables area. Again, for this example, we can ignore the Options button and press OK to obtain the output. In the output for the paired sample t-test, you would normally be given 3 tables of results, one of which is the paired samples correlations. Since we do not need that table for the purpose of this video, we have removed it from the output shown here. Similar to our previous example, the first table provides us with basic sample statistics. Looking at the means, we can see that the mean post-tutorial quantitative reasoning score is higher than the pre-tutorial quantitative reasoning score. In the second table, we are given the results of the paired sample t-test. We can see that the pre-tutorial mean is lower than the post-tutorial mean by 2.18 points. Furthermore, we are also provided with the 95% confidence interval of the difference. Finally, we are provided with the t-value, which is minus 2.309, degrees of freedom, and the p-value. Similar to our previous example, if we compare the p-value to an alpha value of 0.05, we would reject the null hypothesis of no difference and conclude that the post-tutorial score is significantly higher than the pre-tutorial score. Suppose, however, that your desired level of alpha was 0.01. In this case, since the p-value is higher than the alpha value, we would fail to reject the null hypothesis and conclude that the post-tutorial score is not significantly higher than the pre-tutorial score. This brings us to the end of the SPSS tutorial for Chapter 10. We hope that you have found this tutorial to be useful. In the next tutorial, we will look at how to use SPSS to conduct a one-way analysis of variance test.